We're in the home stretch. So all we have to finish for content is 9.2 and 9.3. We are not going to have a specific test over 9.3, or excuse me, just chapter 9. It will be rolled into the final. So we are finishing chapter 9 this week. And then next week, we have what we call basically a dead week. So there's no new material next week. And we will be covering, I'll just be reviewing on the 3 days. So I'm going to break it up. So chapters 1 through 3 will be Monday's review. Chapter 7 will be Wednesday's review. And chapter 9 will be Friday's review. And then your final exam will be the following week. I posted in Eagle Online today. Your final is a take home as well. And it will be due Wednesday of finals week. But next week, I'll touch on that more as well. Like I said, we're finishing 9.2 today. I don't want to push into 9.3. So however much time it takes us to finish 9.2 is what it takes. And then we'll just start 9.3 on Wednesday. So let me share my screen with you. So again, remembering we're picking up a standard deviation. And so what we have here is standard deviation for grouped data. And so when we look at, we still have these formulas, right? We're not doing these by hand. But again, if we use our calculator to find the standard deviation by entering both lists 1 and 2, and then using the 1 var stats. And remember, when we do this in our calculator, we enter 1 var stats. Oops. And then L1, L2. And again, one way to interpret the standard deviation uses the fact that for many populations, most of the data are within 3 standard deviations of the mean. If calculating standard deviation for either a grouped or ungrouped distribution using a rounded value for the mean may produce an inaccurate value. This is usually something that can happen when calculating by hand, which is again why we focus on using our calculator to do this. So we're going to find the standard deviation for this set of data. So to calculate the midpoints, so we want to find the midpoints for each of the intervals. When we did finding just the mean for group data previously, we did the mean we found the midpoints by hand. We can do this on our calculator. So let me reshare my screen so you can see my calculator. And so what we want to do is you can see it says the lower bound plus the next lower bound divided by 2 for each entry. So what that looks like is we're going to do 0 plus 3 divided by 2. Oops, which you can't see because it's behind there we go. Okay. So if we go into stats and we press enter, which gives us list 1 and list 2. Let's clear those lists out. So instead of finding the midpoints themselves, we can let the calculator do it for us. So I'm going to do in parentheses 0 plus 3 in parentheses, and then divide by 2. When I press enter, it will find the midpoint for me. So my next one is going to be 4 plus 7 divided by 2. Gives me a midpoint of 5.5. The next one I'm in parentheses, I'm going to do 8 plus 11 divided by 2. And it gives me 9.5, and then 12 plus 15 divided by 2. And then 16. And again, you have to put it in parentheses so that the calculator knows to add those first before dividing by 2. And then the last one, we're going to do 20 plus 23 divided by 2. So we've got all of our midpoints. So once we have our midpoints, then we just go to the next column, which gives us where we put our frequencies in. So here we're going to put 12, 15, 12, 10, 0, and 1. Again, making sure that we have the same amount in column 1 as we do in column 2. So to calculate the standard deviation, we're going to quit. We're going to do stat, calc. We want 1 var stats. And we want to do, again, L1, comma, L2. And we press enter. And we can see here that our mean, which is X bar, is going to be 7.42. And the standard deviation, which remember is SX, is going to give us 4.729. We can round it off. So that is how you would do for a grouped set of data. So again, I want us to continue to look at this. How many standard deviations from a mean is a set of data? So a medical laboratory tested 21 samples of human blood for the acidity on the pH scale, which gives the following results. So in order for us to find the mean in the standard deviation, we need to tabulate our data. So what that means is we're going to do pH in the first column and frequency in the second column. So if we look through here, our lowest pH is 7.1, and then it goes to 7.2, and 7.3, 7.4, 7.5, and 7.6. I want you to go ahead and fill in the frequency that you find for each of these amounts. And then don't worry about sending me a direct message or anything. I just want to let you have a chance to count this up. So go ahead and fill in the frequency based upon this set of data. So if we look at our set, we can see that 7.1 occurs twice. 7.2, we have 1, 2 of them. 7.3, we've got 5. 7.4, we have 7. 7.5, 1, 2, 3, 4. And then we can see there's 1 remaining, 7.6. So there's our frequency for this. So now go ahead and find the standard deviation and the mean and send me your answer in a direct message. Okay, so if we enter our stuff, we get a mean, or X bar, remember, 7.357. I'm taking it out 3 decimal places just to be more accurate because our data is so close together. And we know our data is so close together because the standard deviation is 0.1326. Okay, and we can take it out even farther if we want, but we're going to go with 0.1326. So it says what percentage of the data is within 2 standard deviations of the mean. So remember, if we think about our mean is right here, and our mean is 7.357. If I had 1 standard deviation above, that means I'm going to take 7.357 and I'm going to add to it our standard deviation, giving us 7.4896. If I had out 2 standard deviations, that means I'm going to add on another of our standard deviations. So 7.4896 plus 0.1326. And I get 7.622. So remember, our highest pH is 7.6, so that's within the 7.622. So we look on the other side. So if we go down 1 standard deviation, that means I'm going to take 7.357 and I'm going to subtract 1 standard deviation from it. And we get 7.2244. And then again, my lowest pH is 7.1. So let's go 1 more standard deviation. So now we're going to take 7.2244, subtract 0.1326. And oops. We get 7.0918. Therefore, because our numbers go from 7.1 to 7.6 and 2 standard deviations out goes from 7.0918 up to 7.622, 100% of the data is within 2 standard deviations of the mean. So we have one last theorem in this chapter, which is the Chebyshev's theorem. So Chebyshev's theorem states that for any set of numbers, the fraction that will lie within k standard deviations of the mean is at least 1 minus k, 1 over k squared. So it says use this theorem to find the fraction of all the numbers of a data set that must lie within 3 standard deviations of the mean. So remember, the normal distribution says that most of the data is within 3 standard deviations of the mean. So if we think about the normal distribution, this lovely bell curve. Hopefully I can draw a little more smoothly. And in the middle, you have your mean. And then we go out 1 standard deviation in each side, another and another. We have 1 standard deviation, 2 standard deviations, and 3 standard deviations. And the percentage of data that's within these, we've got 34%, which means we really have 68% of our data within 1 standard deviation. To go out 2 standard deviations mean we add in another 13.5%. we've got 3 standard deviations. We have 2.35%. And then these outliers is 0.15%. So if we were to add this part up that's within 3 standard deviations, and this is for a normal distribution. So we'd have 0.34 plus 0.34 plus 2 of the 13.5s, which is 0.135 plus 0.135 plus the 2.35, which is going to be 0.0235. And that gives us 0.997 or 99.7%. So if we look at how that relates to Chebyshev's theorem, remember, this is only a normal distribution, okay? And not all data is normally distributed. But for this theorem, it says the fraction of the numbers that must lie within 3 standard deviations. So that means that K is going to equal 3. So we're going to do 1 minus 1 over 3 squared. So if we reduce that, that's going to be 1 minus 1 over 9, which gives us 8/9 or 88.9%. So again, a normal distribution is going to have more of its data within 3 standard deviations versus just this distribution that Chebyshev is referring to. So number 2 says, in a certain distribution, the mean is 40 with a standard deviation of 5. So I included this one because I believe it's in your homework. Trying to find one. Yes, so like this is number 15 in your homework. So the mean is 40 with a standard deviation of 5. Use Chebyshev's theorem to tell the probability that a number lies between 20 and 60. So we first need to look at what is this data doing. So if we have our mean right here, and it's 40. If we go 1 standard deviation in each direction, with a standard deviation of 5, that means we're adding 5 on and subtracting 5 off. If we go another one, so this is 2 standard deviations, we hit 50. Going down, we hit 30. And then going up 1 more, so 3 standard deviations, we hit 55. Going down, we hit 25. And then we want to get to 20 and 60, which means we need to go 1 more or 4 standard deviations to hit 60. And again, we have to be identical on each side. So we're going down 1 more and we hit 20. So how many standard deviations did we have to go? Well, we had to go 4 standard deviations total, which means K is equal to 4. So we're going to do 1 minus 1 over 4 squared, which is 1 minus 1 over 16, which is equal to 15/16. And if we convert this to a decimal, we get approximately 0.9375 or 93.8%. So probability that a number lies between the numbers 20 and 60 is 93.8 or 0.9375. So again, in order for us to answer this question, we first had to apply the standard deviation to figure out how many times we had to do it to figure how many standard deviations out we are from the mean. And then that's going to tell us what our K value is so that we can use it. So again, if you're looking at when am I going to use this in my homework so that I can know when to apply it on the assignment, because for 9.2, there's going to be, they use Chebyshev's theorem on numbers 6, 7, 8, 9. 8 and 9 are that probability example that we just did. Number 15. So it's used a few times in your homework. So put a star on that. Make sure that you note that because you will be using it in your homework assignment. So that wraps up 9.2. Like I said, on Wednesday, I will start 9.3. And then next week, we will go over questions for the end of the class. So any questions for me before I let you go? Okay. Well, again, you have homework 9.1 due tonight. We have homework, what do we got? Where's my scale? 9.2 isn't going to be due till Wednesday. And then when we meet for class on Wednesday, it will start 9.3. So I hope you have a good rest of your day and email me if you have questions. And I will see you on Wednesday, okay? Bye.